Lesson 5, Dot Products. Dot product is a way to multiply two vectors. So let's say we have the vectors u and v. A dot product symbolized by a dot multiplication. So you multiply the x components plus you multiply the y components. And that gives you a single number. So this is sometimes called the scalar product because the result is a scalar, not a vector. So let's find the dot product of these two vectors. So you're going to take the x components and multiply them. So it'll be 5 times 9 plus multiply the y components, negative 4 times negative 2. So 45 plus 8, which is 53. You can use the dot product to find the angle between two vectors, because it turns out that the dot product is also the magnitude of u times the magnitude of v times cosine of the angle between them. So let's find the angle between the vectors 5, negative 4 and 9, negative 2. So the dot product is the magnitude times cosine of the angle between. So the dot product is, well, let's write it out. So it'll be u dot v, then the magnitude of u, magnitude of v, cosine of the angle between. So the dot product is 5 times 9 plus negative 4 times negative 2. Also simplify the square roots. That's 25 plus 16 is 41. 81 and 4 is 85. So 53 equals 41 times 85 is 3485. So divide by the square root of 3485, which gives us about 0.8978. Use an inverse cosine and your angle comes out to be 26.13 degrees. All right, since it's magnitude times magnitude equals times cosine of the angle, well, it turns out cosine of 90 degrees is 0. So if the dot product is 0, then you know that the vectors are orthogonal, which is a fancy word for perpendicular. Well, if the vectors were parallel, we already know that would be a multiple of the other. So if one is a multiple of the other, then they are parallel or anti-parallel if they're going opposite directions. So are these two vectors orthogonal, parallel, or neither? Well, let's start by checking for orthogonal, the perpendicular. So we have to do the dot product. Okay, so I'll have 1 times 6 plus negative 4 times 2. So it'd be 6 plus a negative 8, which is negative 2. That's not 0, so not orthogonal. Okay, let's check parallel. All right, now if they're parallel, one should be the multiple of the other. So so it should be something like that. So we need to find k. So if I do the x components, I'd have 1 equals k times 6. So k would be 1/6. If I check the y components, I'd have -4 equals k times 2. So in this case, k would be -2. Those are not the same. So they are not parallel. Since it's not perpendicular and not parallel, it must be neither. Those vectors are neither parallel nor perpendicular. If you drew them, we could kind of see that. So if we have axes here, one -4 would be like that. 6, 2 would be like that. They're almost perpendicular, but not quite, and most definitely not parallel. You can also use dot products to find vector components. So we want u and v to be vectors such that u equals w1 plus w2, where w1 and 2 are orthogonal. So the w's are perpendicular to each other, and w1 is parallel to v. If that's the case, we'd say w1 and w2 are components of vector u. So you can see on the picture the two blue vectors, they're perpendicular and orthogonal, and they make up vector u. So they're components of vector u. W1 is the projection of u onto v. So if you'd like, W1 is the shadow of vector u onto vector v. If they had light up here, then W1 is the shadow cast by u. And so we write that W1 is the projection onto v of u. All right, so how do we calculate that? Well, we calculate the projection by a dot product, u times v, divided by the magnitude of v squared times v. Like, wow, how in the world does that work? Well, let's work it out, shall we? So, if we work this out, the dot product is the magnitude of u times the magnitude of v times cosine of the angle in between. I'm going to divide this. We have the magnitude of v squared on the bottom, so I'm going to just draw it twice, and I have the v there. So what is this? So that cancels, and I've got the magnitude of u times cosine of the angle. Well, what is the magnitude of u times cosine of the angle? Looking at our picture, that's the angle. Magnitude of u is the hypotenuse. So I have the hypotenuse times cosine of the angle. That gives me the adjacent. The adjacent is the magnitude of W1. And then the second part here, that's v over its magnitude, so that is a unit vector in direction of v. So what we have is the length of u times a unit vector in direction of v. So in other words, the magnitude gives us the length, and the unit vector gives us the direction, and that's how it works. Turns out that that's useful. The dot product's useful in physics. Work is the force times the distance. The force vector dot product with the distance vector. Let's find the projection of vector u onto vector v, and then write u as the sum of two orthogonal vectors. All right, so w1 is the projection onto v of vector u. All right, that's the dot product over the magnitude of v squared times vector v. All right, so our dot product over the magnitude of v, so that's squared times v. All right, for the dot product, I've got 3 times 8, which is 24, plus 4 times 2, which is 8. On the bottom, I've got 64 plus 4. So on the top, it looks like I have got 32. On the bottom, the square root and the square cancel, so it's 68. Okay, oh, I can reduce those. I can reduce them both by 4. So that would be 8 over 17. Okay, so multiply, distribute that. We have 64 seventeenths and 16 seventeenths. So that is the projection to get the other one. I'm going to use the fact that u is w1 plus w2. So I want to solve for w2. So u minus w1 is w2. So that means w2 is u, which is 3, 4, minus w1, 64 seventeenths, 16 seventeenths. Well, we need a common denominator. Common denominator will be 17. So 3 times 17 is 51. And 4 times 17 is 68. So 51 minus 64 is negative 13 seventeenths. 68 minus 16 is 52 seventeenths. So there is w2, and so those are components of u. They're perpendicular to each other, and w1 is parallel to vector v. That's all there is for today. Have a good day.